All right, good morning, everyone, and thank you so much for joining us, and thank you for your patience as we were navigating a little bit of technical difficulties in the background. We appreciate you being here this morning. My name is Carla Morales. I'm the Vice President of the Arizona Technology Council. The Tech Council is a premier statewide trade association focused on technology-based companies. We are excited to welcome you to today's virtual tech speaker series. Today, we will be talking about why good ideas fail, a holistic consideration for creating successful R&D efforts. We have a phenomenal speaker for you today, but before I introduce her, I want to make sure that I remind you all of a few housekeeping items. Please be sure to keep your microphones muted and cameras turned off to ensure the focus remains on our speaker. For today's event, all questions can be put in the chat area, and then we will address those questions at the end during the QA session. I also want to remind you that there are currently sponsorships available for future speaker series events and all future Arizona Technology Council events. All of those upcoming events can be found on our website at www.aztechcouncil.org. Of course, you can always email Jamie Nielsen or myself for more information about those sponsorships. Also, you will get our contact information on the chat available for you to get in touch with us. If you're interested in becoming more involved with the Tech Council, whether it's on our committees, coming to our events, or like I mentioned earlier, sponsoring events or speaking at our events, please be sure to get a hold of us. And as I mentioned as well, our contact information will be available on the chat line. And now, without further ado, please allow me to introduce our speaker for today. Jes Rivas is the Executive Vice President at ILLUME Advising, is a building systems engineer with 17 years of experience in technology assessment, market characterization development, and evaluation. Her expertise spans a wide range of both utility and customer side of the meter technologies, with a focus of emerging technologies, electrification, demand response, distributed energy resources, grid edge, and Internet of Things. Jes is a highly sought after advisor and thought partner and works clients to create strategies to prepare shifts for policy goals and opportunities and funding, including diversifying pipelines and portfolios to create redundancy. And it expands, impacts, and deepens relationships with a service to communities. Please, with that, help me welcome Jes, our Executive Vice President from ILLUME Advising. Jes, the floor is yours.
Thanks, Carla. I appreciate that. I'm going to try to share my screen. I have some slides for today, and I think trying to share slides on Teams is the only thing almost as awkward as sitting through listening to somebody read your bio. Okay, let's see. I'm hoping maybe, Jamie, you can help me know if I did this right. It's going to take just a second.
It looks good.
Okay, thanks for the support. All right. So, my name is Jes Rivas. I'm joining you virtually from Portland, Oregon. It's my understanding that this maybe is a little bit of a switch up from how some of the talks in this series go in terms of maybe that I'm alone as a speaker versus on a panel. So hopefully that works out all right. It is my intention to speak for the first part of our time together, but to leave ample time for discussion and questions if those come up. So, you heard a little bit about me. I have degrees in physics and engineering, and I have been supporting technology assessment in various ways for almost 2 decades. I've written papers and presented on this topic, and most recently, for the past 6 or so years at ILLUME, I've really been working with manufacturers and utility clients to help them really optimize R&D efforts. And to be honest, I think younger me continues to be surprised that I spend so much of my career and time tending to and talking about much of what I'll cover today. And I think in preparing for this talk, I really was thinking about how this all came to pass. And I had a funny realization that I actually don't think I've had, which was that it really was my graduate thesis work as an engineer that I think brought me to this path. What initially felt like a pretty typical and at the time seemingly forever taking mechanical engineering thesis project of creating a tool that could support the accurate estimate of energy savings resulting from the installation of what I'm showing here, variable refrigerant volume heat pump systems in North American commercial facilities, really, for me, was a pivotal experience in understanding the role humans play in the success of technological innovation. So my thesis really was about creating and modeling the impacts of savings that this innovative technology, at least in the North American market, could create, but really underpinned by the understanding that I was trying to create those models to convince all of the relevant market actors of the value of this innovation. And understanding that humans are, in fact, the buyers and users of technology isn't, of course, revelatory. It wasn't then even 20 years ago. And as I'm sure you know, there's a lot of really great thinking out there about the role humans play in innovation, about the role we play in technology adoption. There's even really widely accepted sociological models that describe adoption, that describe the various demographic and psychological characteristics of key adopter groups. There's even bestsellers. The jokes aside, I won't spend too much time on this particular construct because I think it's probably really one of the most widely known and used frameworks. But if this is new to you, this is from Moore's book, Crossing the Chasm, Marketing the Selling of High-Tech Products to Mainstream Customers. And it really dissects and discusses the challenges that technology companies face when we're trying to transition from serving these early adopters, shown really on the left side of this curve, to reaching the broader market of mainstream customers, shown on the right. So in addition to describing this model and the characteristics of these defined adopter groups, which are shown here in these 5 distinct colors, Moore really identified for us the factors that he believes influence adoption and that we have to consider and tend to in our efforts to cross this chasm that exists between early adoption and the rest of the market. Again, this is a pretty commonly understood and widely used framework. And it's really meant to support our understanding of getting commercialized products to market. And so in that regard, this chasm is quite a bit downstream of the work I think that we generally tend to do in R&D. So if we go upstream a bit, we see, not visually here, but another chasm, so to speak, which is really that of tech transfer, which is the process during which we attempt to translate new and innovative research into commercially viable products and services. Tech transfer is really the critical part of any product development's journey, and it can occur between the development and manufacturing stage within or across organizations, which of course creates a lot of complexities. There are fewer Business Week bestsellers written on this topic, but there are really good resources and models and a lot of good discussion in industry about how to make technology transfer successful. But even this, I think, is still a little bit downstream of what I think a focus of our topic for today is, which is research and development. So if we go yet upstream of that, there's yet another chasm with an only slightly more dramatic name, the Valley of Death. And this is how we refer to the gap in support we hit in R&D, where it's difficult to obtain either public funding or private investment during that middle stage of innovation. And in manufacturing innovation, we often call this the missing middle. So lots of names, same concept. And here again, there's resources and models that help us understand why this occurs, and even, really decent guidance on perhaps how to overcome or prepare for these issues. But that said, a lot of good ideas fail. In fact, most new products fail, and across industries, half of new product development doesn't hit established targets. So there's a lot of good guidance out there and still a lot of struggle. And I think there's a lot of reasons why. What I was hoping to use our time together today was to really kind of talk about 2 misconceptions that I think plague innovation at the R&D stage and throughout really a product development's journey. And the first is the belief that a good idea is good enough. So whether we care to admit it, and no matter how much we think we're aware of it, innovation is often really plagued by this nagging and persisting idea that a good idea will be so inherently compelling, it'll generate so much demand that really all these chasms and transfer complexities will be a non-issue. This is hopefully worth a laugh, but there's actually a lot of really good examples why good and arguably or not terrific ideas have failed. So you might disagree that the Segway personal transporter was a terrific idea of our lifetime, but it might have been. This is the self-balancing scooter we still see sometimes in malls or on tours. And it was introduced in the early 2000s as a futuristic mode of personal transportation. And why I include this as an example is it really did have a lot of hype. Some innovation notables like John Doerr, who's an American investor and venture capitalist, speculated that this would be more important than the internet, Segways. Steve Jobs was quoted as saying it was as big a deal as the PC. But I think as we all have experienced, it really didn't achieve widespread adoption. It had a unique design, some potential compelling applications, but there were a lot of factors that limited this becoming a big deal, including limited practicality, high costs, and even some unforeseen regulatory limitations. There's plenty of other good ideas or great ideas I'm sure you can think of from your respective industries and from our lifetime that seemed like winners, but that ultimately failed. So speaking of winners, the second myth I want to talk about today is what I call we'll know it when we see it. And here I'm really referring to the phenomenon of believing that we'll be able to distinguish a good innovation easily and from the rest. I don't know how your experience has been, but in my experience, that's just not the case. In fact, I found that funding agencies and other key actors, and I'll unpack what I mean by that in a bit, often lack comprehensive, transparent, and objective decision-making or even success criteria, which makes it nearly impossible to assess innovation head-to-head and to prioritize investments and change behaviors. So if we look across the journey from R&D to tech transfer to reaching the mass market, there's a lot more myths than those two. And importantly, there's barriers to innovation that plague us. They vary and they're specific to industry and context, but I'd argue that there are some through lines. And one of those is this. I think for innovation to be successful, it needs to be able to demonstrate a sufficiently compelling value to the ecosystem of key actors throughout its journey from R&D into the marketplace. That's a mouthful, but sounds easy, maybe. But let's unpack it. So who and what determines value? Who are key actors? And what are the opportunities we have as we work in R&D and technology to address any of this? Well, we're up against a lot here. To understand the answer to those questions, we have to understand cognitive bias. And this is where my journey as a young engineer with my graduate thesis work and my journey professionally since has been quite interesting and kind of a departure from building science and engineering principles into a deep dive of social science and social psychology. And I've been supported by a lot of colleagues in this work who are not on this call with me, and notably one I'd like to name, Dr. Liz Kelly, whose thought work I'm really also sharing here today. So the good news is, beyond Liz Kelly, these biases have long been researched and discussed and are pretty well understood. The bad news is that in technology, as engineers and technologists, they're often a blind spot for us or undervalued in understanding. So whether we choose to educate ourselves about these or create teams of experts who possess that knowledge to complement our own, I really argue that we need to care about and tend to cognitive bias in our R&D processes. And today I'm going to show you some ideas for how. But first, I want to show you a quick primer on some of the key biases that I think would benefit most to understand. All right. The first one is what we call the 9 times effect. So in Eager Sellers and Stony Buyers, Understanding the Psychology of New Product Adoption, John Gorville really kind of coined this term. And he drew on behavioral economics to present and research this effect, excuse me. So the 9 time effect is the phenomenon whereby the creator of a new product or service values their product or service 9 times more than the customer. And he derived this specific number by understanding the forces that lead customers to overvalue their current solution by 3 times, and product creators to overvalue their new product by 3 times, thereby creating this large chasm between the value a product team sees and the customer sees. That 9 time framework and all of the research really drew from several principles of behavioral economics, another important topic that help us understand and make sense of how and why customers and product creators place the value that they do on products. And the 3 key principles that I think are worth noting include loss aversion, which is really research has demonstrated that losses have a greater impact than gains in the human psyche. Or in other words, that we value the value people place on avoiding the loss is greater than the value they place on the equivalent gain. The second important principle is the endowment effect, which was coined by Richard Thaler in 1980. And that's really the effect whereby we tend to value an object that we own already more highly than the same object if we didn't own it. And finally, there's the curse of knowledge. So the curse of knowledge is the phenomenon when people have a piece of information or understanding, they tend to have trouble imagining or predicting what others without that information will do. So 2 classic examples that I think are pretty intuitive or relatable that have also been proven in studies are that people overestimate the ability of others to find a hidden object if they know its location, or to solve a puzzle that they know the answer to. So hopefully those are relatable. And those same biases plague innovation. So taking a quick break from our primer, let's look at an example. A quick note, I'm talking about R&D, but most of the examples I'll show today are really using commercialized products as examples. And really that's honestly because it's less tricky to talk about them. They're publicly available. And, we're not on risk of talking about anything that is kind of a trade secret. So in the world of building systems, fewer opportunities have been or will likely ever be larger than the opportunity to create efficient lighting. And that's because lighting is ubiquitous and the original design of lighting was radically inefficient. And both those things together offered real low-hanging fruit for innovation and even total market transformation. So one of the most anticipated emerging opportunities for lighting since the CFL and then the LED are what we call network lighting controls. This is a system of connected and individually addressable luminaires or lighting fixtures that allow for all types of multiple control strategies, sophisticated programming, you name it. What I have, the text on this slide shows the long list of benefits that weren't just promised, but that have been proven in field tests that range from dramatic bill reduction, demand response capabilities, to even the ability to do some neat integration with HVAC systems, with inventory tracking, with aligning with circadian rhythms to support our health. Sounds like a winner. There was even a lot of industry experts that weighed in and modeled the really dramatic impact that these systems would have in terms of creating savings at scale. But with so much to offer and so much hype, to date, there really hasn't been widespread adoption of network lighting controls by commercial customers in North America. Our team at ILLUME was lucky enough to support a few clients to investigate why this occurred in their specific regions. And in summary, after speaking to customers, contractors, distributors, and manufacturers, we found that there was really a lack of customer understanding of the perceived value in the benefits of these systems above and beyond the value of even just simple occupancy sensing. There was also concerns about the cost of these systems being too expensive and not having to them what felt like an adequate return on investment over and above LEDs even. And finally, there was both contractor and customer discomfort with new technologies named as a barrier, including the concern about networked technologies more broadly and the security risks, which is interesting in a modern day where so many of the things we rely on day to day are connected. So to that, let's return to our cognitive biases. There's a couple more I want to talk about. And one of them that loomed large in that finding, or that example rather, is this status quo bias, which is the cognitive preference for an overvaluing of the item or object that we already have. So this was another concept introduced in the 80s when researchers found that when participants had to make an important decision, they showed an overwhelming preference for the option that maintained the status quo. So by instinctively preferring to keep things the same, people attempt to minimize risk and minimize specifically the risks involved with what they perceive as the change required. And as such, they intuitively reject new technology and downplay the benefits it offers. So status quo bias is often observed in people's attitude toward emerging technologies that require change to their current knowledge or habits. Speaking of habits, the last part of our primer I wanted to cover is really about culture and norms. So social norms refer to the shared unwritten rules, values, and standards of acceptable behavior determined by society. Through observation and socialization, people learn from these social norms as a guide to their social behaviors and their understanding of society. It's really the how things are done around here effect, right? So one more example. This is an evaporator fan. It's used in commercial refrigerator walk-in and reach-in coolers and freezers, right? So if you go to a gas station, you need to get a cold drink, you open up or reach in to a cooler. This is the kind of fan that is responsible for helping keep that unit cold. This particular fan is driven by a permanent magnet alternating current synchronous motor, which is a pretty neat, slick motor. About 5 or 6 years ago, R&D teams were working to bring this motor to like commercialized products, and they were doing a lot of, they had done prototype testing, lab testing, they're out in the field testing it. And ultimately, they found that in these smaller horsepower ranges, these smaller fans, these motors could save a ton of energy. They could save between 52 to 83% when replacing the permanent split capacitor or shaded pole motors that are common to this application and customer segment. And what's more, the retrofit process for swapping these out was relatively straightforward. As long as the technician conducting the retrofit had prior refrigeration experience and requisite tools, the retrofits were quick and smooth. In fact, based on average electricity rates, labor costs, and the incremental price of this product, the simple payback was less than 2 years, which is a generally compelling payback for energy efficiency technology in the built environment world. So they were brought to market. They were made commercially available. A Midwestern utility even expanded their commercial program portfolio to provide financial incentives or rebates to encourage the adoption of these motors, and yet they really were largely unadopted. So here again, our team was able to go and conduct some research to understand the reasons for the lower than anticipated uptake. And in short, we found that service contractors are the trusted advisors of the buyers of this product. That means that consumers really rely on a different person to tell them what to buy. And in this particular application, those are service contractors. Those are refrigeration service contractors. And those contractors prefer like-for-like replacements. They didn't trust that this product was only offered by one manufacturer at the time. They felt that the new motors didn't offer significantly compelling benefits beyond the current products to warrant investing in training. and adding them to their product lineups. And they shared that in their perception, the refrigeration market is not standardized, and that there's so many proprietary systems and specific configurations, and that the importance of keeping items cool for their customers is so high that they believe that only identical replacements could reduce their risk for customers and reduce their chances for callbacks. Reasonable. Feels reasonable. So circling back, to understand what we're really up against when we think about bringing innovation through R&D into market, quite simply, we're up against cognitive bias. Excuse me. Oh, and we really need to enhance our understanding of these so that we can understand the role we can play. And to me, it really boils down to two truths. Change is hard, and people trust who and what they know. So how can R&D help with this? Well, I think it can help it in several ways if we're open to it. And to start that conversation, I wanted to put up on a slide a hopefully recognizable and generalizable R&D process. So I'm showing here, from top to bottom, the phases as we move through R&D from basic research to applied research to prototyping, and then ultimately to piloting and scaling. And what I'd like to do as I pivot to the second part of our chat is really to take these general phases and discuss a few ways we can start to account for and tend to cognitive bias and other human and market factors in our R&D work. Namely, I think we can do that by incorporating additional research and tests into these existing phases. So this arm of research, while relatively mature and perhaps even intuitive, and by that I mean social science, behavioral science, social psychology, it's commonly undervalued as a useful investment of resources at the R&D stage. But what I'm hoping is to further, to convince you otherwise, and perhaps if you're already convinced in doing this, to give you some additional ideas and considerations for how to consider this in your work. So to start, looking back through that long and bumpy road, we really need to understand the key actors at the critical junctures of the journey, or along the journey rather, from research to adoption at scale. And I've said key actors a few times, and what I really mean here is any investor, funder, decision maker, influencer across all the relevant and enabling industries that we touch on our way to ultimately the consumer. And for each actor, what we want to do is understand as much as we can. What do they know? What are their sources of information? Who are their trusted advisors? And ideally, we map that. So the image I have here, that's maybe an eye chart, is an influence map for the network of market actors that have anything to do with water heating, notably tankless water heating. And as the name of this tool implies, this map isn't meant to simply identify who are the set of actors. It's meant to also help us understand how they relate, how they know each other, how communication flows, and in this particular map, who influences who. As shown here, consumers primarily rely on installers, either plumbers or HVAC contractors, depending on the product type and region. Tankless water heaters are kind of a weird thing. But consumers rely on installers for information about information and recommendations about their water heater replacement options. Installers generally say they'll install whatever their customer wants, but truly, installers rely on manufacturers, reps, and distributors for their product information and trainings. So what tools like this and exercises like this can help us understand is that in this specific case, to improve installers' familiarity and awareness with any innovation in water heating, we need to consider creating and testing interventions that leverage the trusted relationships of installers. And if we do that really well, we do this research and we do testing to complement it, we can also understand what's the most effective intervention. And by that, I mean, is it testing data? Is that sufficiently compelling? Is it field validation? Is it hands-on experience or product ownership type models where installers get to install these in their homes and have, that kind of lived experience of a product? Is it something else entirely? That's what we should seek to understand at the earliest stages of R&D. And to be clear, there are lots of tools that we can use to investigate this, and we can kind of tailor those to the type of actor we need to influence and understand. This example is an empathy map. This is another really commonly used tool, often for way downstream in the adoption journey. So this is something, by that I mean we really have used to understand customers or the ultimate end user or consumer of a product. But they're really neat, and they can honestly be designed to understand any actor. So what you do is you place said actor at kind of the center of this map, and you want to understand the world for them. What do they see? What do they think and feel? What do they hear? And what do they say and do? And this might, again, feel maybe intuitive or hopefully not painful, but it's a deeply informative and worthwhile exercise and a powerful tool that can help us understand really what interventions we have and need to consider. As a part of creating any such map or understanding, we have to also go back and understand the relative status quos and norms that exist for those actors. So, Gorville, the creator of that 9-time effect, it really suggested that product researchers and developers consider the behavior change they're asking of actors or consumers to support or adopt a product, and to focus on the trade-off between the current norm and the new norm. And he suggests, again, probably intuitively, that products or innovation that offers a significant increase in value without requiring too significant a behavior change are the easier to adopt, of course. But he also notes that products that offer significant product value and require significant change, like moving further away from a like-for-like replacement in the example of the motor, might be possible, but will require an even longer ramp-up period and honestly more investment to enable gaining familiarity and trust with products. So just to, again, try to show some tools, there's some really neat ways to understand or map social norms, status quos, or kind of like the world of barriers as we discuss them. This is a barrier map. From left to right, what we're showing here on the x-axis is what was seen as like a negative impact about, in this case, the water. I'm staying with water heating innovation. This is a gas heat pump water heater, meaning a natural gas powered heat pump water heater. So moving left to right, things that we're seen as having a negative impact on influence versus a positive impact, and from top to bottom, or rather on the y-axis, going from the bottom to the top, the importance, or excuse me, the relevance to this specific innovation. And then using 2 different colors, what our team was able to do for this research was show where customers fell on this map compared to installers. And remember, that relationship is really important. Customers defer to installers. And so we really want to understand, like head to head, how did some of the considerations around installing or adopting new water heating technology fall. So just as an example, we have installation time. These are relatively quick products-ish to install, or rather installation time has a positive impact on installers wanting to promote a product. The quicker it is to install, easier for them. Gas heat pump water heaters, not the quickest thing to install, so that's kind of in that bottom right quadrant. And you can see there's a lot of different things on here. This is again just one example, but wanted to show it as I think it can be quite meaningful to see, and can be done really for any product. All right, I want to be wary of time. So finally, we really have to start being really honest with our own bias, right? How valuable is the innovation we're working on really? And not just in our perception, but in the perception of the folks whose support we really need. So I think in reality, we really need to create compelling value propositions for those people. So we need to meet people and we need to overcome our own curse of knowledge, right? And meet people where they're at. Nobody's willing to embrace the pain of change unless they can really see the potential for a better future on the other side, including both new opportunities and ways to avoid the loss that they'll experience along the way. And if all of that wasn't messy enough, this really requires that we consider and plan for decision making, because in a lot of ways, decision making is the collision of all of those cognitive biases and norms together with business and organizational objectives and goals. So it's a mess. That's why I said before, when I showed the horse race and hopefully made an analogy that was somewhat compelling, a key actor or organization's decision and success criteria aren't always totally clear, objective, or even repeatable. And we need to care about this, because we can live and die by this ambiguity in decision making. So here again, I think we benefit to bother to research and understand how decision making works for the key actors that we'll be interacting with. And we can create maps and tools to support this. This is a super rudimentary model, but can go a long way. Here we're talking about on the x-axis, low market barriers to high market barriers, and on the y-axis, low savings to high savings. And then we're left with this kind of decision-making quadrant. And as you can imagine, high savings, low market barriers, top left quadrant, those are the easy wins, high priority. So, this is where investments are probably most likely to be green lighted, versus maybe the bottom right corner, that quadrant, low savings, high market barriers, that feels tough. And this kind of, again, this can be customized to at what point we're at in that long journey and what the considerations are, what success criteria looks like. But the other thing I just want to say that we have found really helpful in supporting manufacturers and clients, especially where there's portfolios of R&D products or R&D work going on, is that creating maps like this also allow us meaningfully to compare innovations head to head and better inform investments, which is really another sticking point. So circling back to those kind of generalized R&D phases I showed, here's just one way I think that we can consider creating this kind of parallel path of sorts designed to help us understand and ideally overcome these human factors that tend to limit innovation. And that's what I've shown here on the text on, I think, the right-hand side. For lack of a better word, I've kind of like posited that there's like the technical path we tend to follow in R&D, and this is now this human path. And I really think that this practice of understanding and even mapping key actors can begin at the most basic research stages. It's also a nice gut check to make sure we're creating solutions to problems that actually exist versus a solution looking for a problem. So I think at that very first phase, we need to understand who's going to care about this product, who do we need to convince the value of this product to. And then as we move into applied research, what is the information we need to do that? So I've characterized that here as identifying the barriers and potential interventions to overcome those barriers. And then even to start at this stage, at the applied research stage, to flesh out what an intervention might look like. And again, at the very upstream new R&D, that could be simply getting recognizable research together for both the technical and non-technical stakeholders that are going to be a part of those initial decisions that support funding or investments. And the path finding and prototyping stage is really where we should bother to test the interventions. Is the data that we pulled together, is the educational materials, what have you, is it going to be compelling? Is sufficiently compelling that will overcome the barriers we're going to hit? And then scale that up as we go to pilot, continue to test those, and as we go to scale, are our interventions cost effective? And will they make adoption achievable? As a final slide, I wanted to just acknowledge that that's super rudimentary, and that I really do believe, and that's been our experience, that this as just a kind of loose framework is highly customizable, and that the considerations of technology versus human can really be expanded to be much more comprehensive, as comprehensive as it needs to be. So this is an example from a different portfolio that of R&D that we oversee here at ILLUME. And from top to bottom here, what you're seeing is kind of a reframing of those phases of R&D. So the top still looking at technologies and market characterization, moving down into demonstration and market development, as we've called it, and of course, kind of ending in the holy grail of scaling. But instead of just technology and market, what we've shown here is kind of a 5-stream consideration. So there's all the technical considerations you might expect to see, but for this particular R&D portfolio, there's other very specific considerations of building integration, of workforce, of customers, and then also of regional markets. And what's helpful in these more comprehensive type frameworks is that we can also consider and identify enabling technologies, actors, and things like policy that should also be accounted for and attended to in our journey through R&D. So maybe one more funny technology example, but that's what I wanted to talk about today. I wanted to try to leave time for questions and discussion, and I think I did.
You did. Thank you so much, Jes.
Sure.
I haven't seen any questions on the
Great.
chat, but I want to definitely open up the floor for anybody that's joining us today. If you have any questions, feel free to open up your microphone and your camera, either or both, and ask your questions directly to Jes. Actually, I was going to say thank you so much. That was a very extensive and very well explained research and development. I think I particularly liked the conversation you had about the biases, and the one thing that really stood out to me was the 9-time effect. I think it's important for us to really consider the perception that as producers and consumers, and how they intertwine and how they come together. So I appreciated that. I actually did have a question for you, if you could possibly elaborate, and I know you touched on it a little bit. Would you share a little bit more about how you would encourage and facilitating the collaboration between the technical teams and the other stakeholders, like the marketing or end user experience, to ensure the holistic approach to R&D?
You know, it's such a good question. And I think, and honestly, it's one of those things easier said than done, right? Because it's our experience, and this is probably a shared experience, that often in so many organizations, and for good and bad reasons, a lot of this work and teams are siloed. So it's not necessarily as simple as being able to immediately have a conversation. So I think it can look a lot of different ways, but it's certainly been our experience and hope that and I'll be honest, it's been tough work to try to get all those other players. So, you know, who would represent the non-technological work to conversations at those, or, you know, kind of initial stages of R&D. I think even that has gone a long way for our clients. They're kind of like internal stakeholder meetings, right? Like, who's ultimately going to care about this? And can you either be involved in this journey, or can you help inform the planning of how we're going to approach it? And at what milestones can we check back in together?
Yeah, absolutely. And I think it's important, as you mentioned, is understanding the challenges and the biases, the cognitive biases that we bring in to our production and to our idea process. From your experience, what are some common pitfalls in R&D that, and how can an organization learn from those failures, from those mistakes, from those challenges to improve their future endeavors?
That's a good question. I'll be honest. I think I have a lot of sadness about some of the pitfalls, because I feel you know, getting to work in the way we do, we can look across. We've worked with people kind of across North America, and it's I think it's sad to see, the same pitfalls plague us, especially with so much, dedicated resources and brilliant people working. But I really do think one of the bigger pitfalls we've seen is really getting to these critical handoff moments, whether it's like the next step in funding or transitioning from, like the lab to fab kind of moment, failing. That we've just seen that moment, things just die on the vine, and people just be so like confused about, we thought we had like packaged this up, delivered it on a silver platter, or had this winning idea, what have you, and we've just seen it really die on the vine. And I think for a lot of the reasons we talked about today, but also I think maybe one that I didn't address so specifically, which is often the people with whom we're expecting that to reach out and like get that, whether it's, like I said, funding or even just like now the ownership of manufacturing it. We have to understand they're living in their own world too. And for a lot of people, this is just one more thing. And so it's also, I remember once this really brilliant person we were talking with, she drew a circle of like all the stuff she works on and her time and capacity to care about this thing she was supposed to inherit and tend for, right? And where does that fit? It was a tiny invisible sliver in like the world of stuff that she really needed to care about. And while maybe surprising, I think we can relate that our jobs and, organizationally are sometimes not even necessarily optimized to make time to support at the level we need to. So all that is to say, I really think it's what we tend to do is to look down the line and try to bring an awareness of all those future actors as upstream as we can to engage them and to kind of ready ourselves to make these handoffs work.
Absolutely. I appreciate that, because you're right. I think there's a clear balance between the transactional and relational components of this. So I see that we do have a question in the chat now. The question is, Brian, would you like to ask your question, or would you like for me to read it?
Sure, I can ask it.
Perfect.
I love the theory here and the framing of this, and it's really aligned with my own personal experience with tech transfer and working with utilities. But I'm just wondering if you have any sage wisdom about making the strong business case for this with clients up front, so that they see that if they're going to be wasting time and resources, if they don't sufficiently allocate budget and resources and timeline to looking at the human side right out of the gate.
Yeah. I love that question. I appreciate the hope that I had sage wisdom. No, the truth is, gosh, this has looked a lot of funny and different ways for us. I think you're right. We experience this continually. I think for us, where I feel like, and for other work I've seen where this has had the most success, is honestly in really trying to get to know how to create a value proposition for the decision makers in the within your client network, and to try to speak their language. Honestly, for better or worse, talking about risk, and this being all like a risk avoidance plan especially for utilities who live and die by risk and regulation and compliance, we've sometimes found to be far more compelling than trying to talk to them just about like the value of caring about humans. And so I hope that makes sense. So like framing it in a thing that feels very meaningful to them has been helpful to us.
Yeah, thank you.
Sure.
Thanks, Brian. Is there any other questions? Well, I know a question that I was asked directly is, will we have access to your presentation for today? There was a lot of great information. Will you be able to share that with us today so that we can share it to the registered attendees? Perfect.
Yes, happy to.
Thank you. We appreciate that. Well, without further ado, I'm going to go ahead and say thank you, Jes, so much for your time and sharing your subject matter expertise and sharing your resources with our attendees and the Arizona Technology Council members and guests. We would also like to thank the University of Advancing Technology for being the presenting sponsor of our virtual Tech Speaker Series. We encourage all of you to join us at our upcoming events. If you haven't registered already, we have our Cybersecurity Breakfast Forum to December 7th, Thursday, December 7th. And then we have our Tech the Halls on December 13th in the Phoenix area. And then the After 5 Holiday Mixer here in Tucson on December 20th. And of course, we will have our Arizona Photonics Day celebration, January 24th through the 26th at the University of Arizona Tech Parks at Rita Road. I want to thank all of our attendees for joining us and participating today. We encourage you to visit our website at www.aztechcouncil.org for all future events. And we thank you all again. Have a wonderful day. And if we don't see you at the upcoming holiday events, happy holidays and enjoy the rest of your week.
Thank you, Jess.
Thank you.
Thank you.